Hello and welcome to part 4 of our pre-calculus semester 1 review. So we are going to go through and do the rest of this. So if you take a look at number 44, 44 has us using our unit circle. Remember, this is the non-calculator portion, so you cannot use a calculator to do this. So the first part says find the cosine of 7 pi over 6. Well, what I'm going to do then is think about what the cosine is at 1 pi over 6. 1 pi over 6 is our 30-degree finger, so I'm going to put down my 30-degree finger. What is the cosine? Well, the cosine is the x value. So I know at pi over 6, the cosine is radical 3 over 2, which means at 7 pi over 6, the cosine is also radical 3 over 2. But we have to decide if it's if it's positive or negative. 7 pi over 6 is going to be in quadrant 3. Well, in quadrant 3, everything's negative, right? Negative, negative. So I know that this is going to be negative radical 3 over 2. 135, well, that is going to be a reference angle. How far is it from 180? That's how you find your reference angle. To get to 180, you need to add 45. So sine of 135 is the same thing as sine of 45. Well, I know that at 45 degrees, the sine, which is the y value, is the square root of 2 over 2. So I know this is square root of 2 over 2. This is the sine of 135, so it's in quadrant 2. Is the y values positive or negative in quadrant 2? And they are positive. So this is also going to stay positive. The tangent of 315, well, now we're all the way over in quadrant 4, so we need to figure out how quick we can get to the 360 degree mark. And again, it's going to be 45. I'd add 45 to this and I would get to it. So I know that tangent is going to be based off of the 45. So again, think about what happens at my 45 degree reference angle. Tangent is the y divided by the x. So radical 2 divided by radical 2, well, that's 1. But in quadrant 4, we have to decide if it's going to be a positive or a negative tangent. In quadrant 4, the x's are positive, but the y's are negative. So if I divide a positive and a negative, I get a negative. So it's going to be negative 1. Part D says to figure out the secant of 5 pi over 4. So that's another fourth. So I know my fourths are my radical 2 over 2s. Secant is going to go with cosine. So it's going to be matched up with the x value. So square root of 2 over 2, but since it's secant, I need to do the reciprocal. So the reciprocal of square root of 2 over 2 is 2 over the square root of 2. And we'll go ahead and rationalize that. Then multiply by radical 2 on top and bottom. I get 2 radical 2 over 2. The 2's cancel and I get square root of 2. Now I got to ask myself, well, again, this was cosine, so it's the x value. Are the x values positive or negative in this quadrant? Well, 5 pi over 4 is definitely going to be in quadrant 3 because it's bigger than 1 pi. Quadrant 3. Everything's negative in quadrant 3 except tangent. So I know that that's going to be a negative radical 2. And last but not least, find the secant of negative 3 pi over 2. Well, we're going negative now, so remember that negative means we go the opposite direction. So pi over 2, pi, 3 pi over 2 is going to put us here. Again, secant is the x value. Well, the x value here is over 0. So that means we have to take the reciprocal of 0. There is no such thing as the reciprocal of 0. 0 can't be a reciprocal. So since I have to take the reciprocal of 0, I get undefined as a solution. It's going to be undefined because the cosine of 0 doesn't have a reciprocal. All right, 45 says draw the angle negative 2 pi over 3 in standard position and then label all these parts. So we know because it's negative, we're going in the clockwise direction. To get to 1 pi, we'd have to go all the way around, but this isn't quite 1 pi, it's 2 pi over 3. So we're going in thirds. So here's 1/3, here's 2/3. So this would be negative 2 pi over 3. The initial side would be the x-axis we started on. The terminal side is where we ended. The direction of rotation would be where we add our arrows. Some of you may have already done that because that's how we learned it. The quadrant or axis where the angle terminates, well, that's going to be in quadrant 3. And the exact value of the point for which that rotation happens. Well, let's think about what happens. We know that at pi over 3, this is a pi over 3 reference angle. At pi over 3, I get 1/2 and radical 3 over 2. 1/2 radical 3 over 2. And then we just got to acknowledge our signs here. Since it's in the third quadrant, my x is negative and my y is negative. So it should be negative 1/2, negative radical 3 over 2. 46 says, which of the following is not coterminal with 30 degrees? So all we have to do here is think about what happens if I add or subtract 360 increments. If you take 30 and you subtract 360, would you get negative 330? And you absolutely would. If you take 30 and you subtract 360, would you get negative 30? No, so that's not going to be coterminal. If you take 30 and add 360, would you get 390? Yes, so that is coterminal. And if you take 30 and add 360, you get 390. Add 360 again, you would get 750. So that is also coterminal. As long as you can add or subtract 360 to get those numbers, they're coterminal. Negative 30 is the only one we can't do that with. All right, 47. Given that point P, negative 512, is on the terminal side of theta, an angle in standard position, find the exact value of each of the following. So remember, we know that cosine is that SOHCAHTOA is adjacent over the hypotenuse. Or you could say x over, in this case, r, the radius or the hypotenuse, either way. Sine is going to be opposite over hypotenuse, which is y over r. And tangent is opposite over adjacent, which is x over y. That's not right. Sorry, y over x. Y over x. What am I doing? Stop it, Mr. Nakarado. Y over x. Sorry. So let's go ahead and get this picture drawn. I know that I'm graphing this point negative 5, positive 12. It's going to be in the second quadrant, somewhere about there. If I draw this right triangle that would be constructed from that, I know that this right triangle has a leg that goes out 5, because it was negative 5, and then up 12. So I just need to find that missing side, which means I'm going to have to use Pythagorean Theorem. A squared plus b squared equals c squared. Some of you may recognize that Pythagorean triple. 5 squared plus 12 squared equals c squared. It's going to be 25 and 144. Again, this is no calculator, so you better make sure you know these numbers. 169 equals c squared. That's a big one, but the square root of 169 is 13. So I know this other side is 13. So now I can go through and I can actually find my answers. Whatever way you want to do it, adjacent over hypotenuse or x over r, I don't care. This one is going to be negative 5 over 13. This one is going to be the opposite 12, or the y value 12 over the radius 13, so 12 over 13. And my last one is going to be y over x, so my 12 over my negative 5, which is going to be negative 12 fifths. .48 says, given the trig function 7 sine 4x minus 2, identify the amplitude, the horizontal and vertical shifts, and the period. So amplitude's easy. Remember, that's the number in front. So in this case, there's a 7 in front, so the amplitude is 7. My horizontal and vertical shifts come from the inside and the outside of the parentheses. Well, there's nothing being added inside the parentheses, so there's no horizontal or phase shift. But there is being something added or subtracted on the outside, so that's my vertical shift, which is negative 2, so I know I'm going to go down 2 units. And the period, we take 2 pi and divide it by whatever is in front of the x value. In this case, there's a 4. So I simplify 2 pi over 4. That's going to be pi over 2. So the period of this function is pi over 2. 49 says, what is the range of the trig function? So we know that ranges for our sine functions are always from negative 1 to 1 as their parent function, because it oscillates negative 1 up to 1, back to negative 1, up to 1, back to negative 1, up to 1, right? This has an amplitude of 3 though, so it's going to change our amplitude, or sorry, our minimum maximum range values a little bit. Instead, it's going to be negative 3 and positive 3. So it's going to stretch the graph, so the range is now 3 and negative 3. But there's one other thing we have to pay attention to. The graph has also been shifted down 1 unit. So if I move the negative 3 down 1 unit, now it's at negative 4. And if I move the 3 down 1 unit, now it's only at 2. So there's still a range of 6 values. There's still 6 numbers in between there. But because it got shifted down, it's going to be a little bit different. So I can see that my answer is the range is from negative 4 to 2. So in interval notation, because it says write it in both, we'd put a bracket, because it can be negative 4, to 2 with a bracket. There's my interval. Set notation, be careful, we're looking at the range. So this is the y value such that -4 is less than or equal to y, which is less than or equal to 2. There is my set notation. This is just a straight line. Remember, set notation is y such that y is in between -4 and 2. Next one says, what is the phase shift of the function? That's easy. Phase shift is just represented by the piece being added or subtracted inside the parentheses. So it says minus pi over 4. So I know that means go to the right. It does the opposite of the sign. So go right pi 4th units. All right, on to our last page, 51. It says, what is the period and phase shift of the following function? Well, they already factored everything out on the inside, so we're good there. I have my 3/4 factored out. So my phase shift is going to be this part right here. It says plus pi over 4, so I know that means go left pi over 4 units. So it can't be D or B that say to the right. It has to be A or C. Next is determining the period. So to find the period, we take 2 pi and divide by whatever we factored out, which is 3/4. So that means that I can rewrite that as a fraction times a fraction. So 2 pi over 1 multiplied by the reciprocal of the denominator, 4 over 3. 2 pi times 4 is 8 pi. 1 times 3 is 3. So it looks like my period should be 8 pi over 3. So A is going to be my good answer there. Period of 8 pi over 3, and move to the left pi over 4 units. 52 says, given this graph where it's written with increments of pi over 2, so each unit is pi over 2 units, which one matches that equation? Well, I can see the first thing here I notice is that the maximum is 2 and the minimum is -2. So the 2 up front makes sense. The next thing I'm concerned about is the fact that this is definitely a sine curve because none of these have phase shifts. It starts at 0 and it ends at 7 pi. So if I take 2 pi and divide it by whatever is in front of x, I should get 7 pi. So we'll just call this value A. A is going to be either 7, 4, 2/7, or 1/7. Let's figure what that is then. So I'm going to multiply both sides by A. That cancels, and I get 7 pi A. So 2 pi equals 7 pi A. Divide by 7 pi, divide by 7 pi. The pi's will cancel. My 7 pi's cancel, and I get 2/7 equals A. So it looks like C has to be my answer so that I can make my period stretch over 7 pi units. 53 says, what is the definition of a radian? Remember we talked about how a radian is if you take a circle and take the radius of a circle, and you were to take that radius and stretch it out across a circle, whatever we get there is representative of 1 radian. So a radian is the central angle, theta. That was a theta I tried to draw there. It was very ugly. The central angle, theta, of a circle whose, not a circle, sorry, of a sector whose arc length is equal to the circle's radius. So whatever this central angle is, if the arc length is equal to the radius, then that theta, that central angle, is a radian of the circle. And then this says, what is 1 radian in degrees? Keep your answers in terms of pi. So, well, that's kind of a weird one. 1 radian, we need to convert it into degrees. So we're going to put pi radians on the bottom and 180 degrees on top. My radians will cancel. So 1 times 180 is 180 degrees. And then this is technically a 1. 1 times pi is pi. So 1 radian in degrees would be 180 over pi degrees. And that brings us to the end of our review. Again, if you have any questions on it, please let me know. Bye, everybody. Thanks.